Hey guys, welcome to shop. So this is going to be part 2 of our Dum Dum's Guide to Machining, and we're talking about the manual engine lathe today. Now this is again a very surface level, superficial approach to discussing some of the tools and techniques in a manual machine shop. Now if this is the kind of content you enjoy, please like, comment, subscribe, and share. This particular machine is a Chinese-made model. This basic casting, headstock, all of this, there's quite a few people who sell them in the US. This one particular machine is badged as a Grizzly Model 4003 gunsmith's lathe. If I understand, the difference between this and the 4003 is you have different bearings in the headstock. You have a slightly larger spindle nose for a heavier duty chuck, and it comes with a couple of other features. Now overall, pretty decent machine. You can do what you need to do on it. And we can run through a quick overview of just all of the things you can do on a manual lathe. There is obviously external turning, there's internal boring, there's internal and external threading. You can face parts. There are ways to set this up as an indexer and cut gears on it. That is not a task I am comfortable achieving. You're more limited by what you think you can do than what the machine can actually do. Today we're just going to do a very simple demonstration on external single point threading. It's quick, dirty, fun to watch. Now, overall, people will call the lathe the king of machine tools or the queen of machine tools. I don't know if I necessarily agree with that attitude, but they are extremely versatile machines. They're also a lot simpler to operate than a drill press. They are in a way simpler to operate than a drill press. At least when you're just looking at external turning, they're really straightforward. You just have to start thinking differently. And they're certainly less complicated to set up than a milling machine. And they're also a lot less expensive. So on a drill press, if you're just banging a low precision hole, they're easy. But when you get into actual complicated setups, there are ways to fixture on this for super precision production jobs. And by super precision, I mean really within a couple thousandths of an inch hole locational accuracy and squareness. It's just, as we go forward, the machines get more and more complicated and less tolerant of errors. You can still get good results without a lot of skill or experience on a drill press. But lathes are a lot less forgiving. If you want to get good results, you really got to put the effort in and take your time, do it right. Sharp tools. And I know a lot of people hit on this. I do have a hard time recommending or telling someone to go with high-speed steel, shop ground, or brazed carbide shop ground, or insert tools. Now, I have a combination of the three. Lately, I've been using mostly brazed carbide tools I grind in the shop. Not necessarily the best option, but it's just the option I've been pursuing. Now, you can also go with insert tools, are really easy, but when you're getting started, you break tools a lot. And high-speed steel is, generally speaking, the most tolerant of shock loading, and it's also, it's kind of just idiot resistant, guys. When you're getting started, you're going to make a lot of mistakes. You're going to break tools all the time. You're going to have a hard time with it. I think a lathe does have a learning curve that's much steeper than a drill press, but not nearly as steep as a milling machine. They are significantly easier machines to understand, and this does look like it has a ton of knobs, buttons, levers, and what have you, but you're not using most of these. On the milling machine, you're using 4 or 5 or 6 controls on every operation, and you're going to be cutting left, right, away from you, towards you, up and down. You're working in truly 3 axes. You're only working in 2 on a lathe. because fundamentally the carriage will move looking at it. It moves to your left and your right, and the cross slide moves in and out. Now, yes, you do have a compound, and the compound can move in and out too. But here's the thing. You don't need to use the compound. So you can pretend this compound doesn't exist for most jobs. Now, I also know there's a lot of people on these smaller machines who just completely remove the compound because it is a source of rigidity trouble. And this will flex. But I think the benefits of having it are worth the downsides. You may think differently, but we're getting off in the weeds. You can still think in a two-dimensional plane on a lathe. And you can certainly think in 2 dimensions on a drill press because you're only drilling from the top down. Once we get into the mill and the surface grinders, you really have to start thinking in 3 dimensions. And I think that's one of the reasons that a lathe is easier to use but less intuitive. And people often approach these and seem, on the surface, this appears to be a little bit more complicated. Well, the part's turning and I have this one cutting tool, how do I do that? And fundamentally, I think I can appreciate that as, not a novice, but someone who has less experience than a lot of other people. But the thing is, just because it's intuitive on the surface doesn't mean it's intuitive once you get down to the nitty gritty. Now, once you start thinking of the part is what's turning, and if we just pop this out in between gears, it's a little easier to turn the shock. Now, that is one of the complaints I have about these Chinese lathes, is they can be quite difficult to shift, and it does require a little bit of effort. The controls aren't the nicest on this. It's still a good enough machine for what I paid. And what you might pay for one of these, they're still good enough. There are better machines out there in that price range, but you start to look at really large industrial machines that might even fit this entire wall. So, just think about that. Space savings is important. I scraped the bottom of the cross slide in the compound. That's made a huge difference. Long term, I would like to partially disassemble the machine, and I would like to scrape the dovetails on the saddle, but I think that's a long-term goal. And we're getting beside the point of this. This is just this is what a lathe is, and this is what it does. And you can see this is a dead center. I turned this for a job. There's a lot of different tools you can make on the lathe that are relevant to the shop. I will turn arbors for cutters or to put parts on. You can make punches if you need a specialty punch. Again, you're more limited by what you think the machine can do than what it can really do. And also, you can bore bushings. So a good example of this is if you're familiar with how an excavator goes together, the boom hinges on pins, but inside the boom, there's a bushing of relatively hard material, ideally harder than the pin that rides within that bore, and you have your pin and your bushing. So a good example of a job you can do on an engine lathe, and this is something I have done, is made a replacement set of pins and bushings. Now, in an ideal world, you will hard turn those. So hard turning is using cubic boron nitride or diamond tip tools. And you're able to machine materials that are harder than Rockwell C45, which is the upper limit of what you can do on quote-unquote conventional carbide tooling, because you want a really, really hard pin and bushing, at least on the surface. And again, we're kind of getting off track here a little bit, but it is informative, and it is fun to think about these things and give practical examples of what can be done on this, other than if it's round, I can figure out how to do it on a lathe. And you also don't have to work on exclusively round parts. Now, an example of that, and I've seen people do this, is actually the carburetor mounts on some motorcycles, there's restriction in them because they can be bored out larger than they are. So you can mount one of those on, let me grab it. This is called a faceplate. So you could mount this not round part, but with the actual round part you're working at running true in the center of the faceplate. And that is oftentimes easier than boring said part on a milling machine, especially if it's long, because I can work on this about a 28, 30-inch long part, and that can be quite difficult to fixture on a milling machine. So, another good example, I have it on here. We have a pipe flange, and this was just smaller than I needed it to be for a specific task that's as of yet not completed. So I just put this in the lathe and I bored out the center and made it to the right size. So you can do a lot on these machines that you might not see initially. And there's also a lot of tasks on these machines that I don't know I can do yet because I haven't had the opportunity or been forced to figure it out. Where one of the really fun things as we get into these progressively more complex machines is that we can tackle progressively more complex tasks. And there really is a tremendous element of creativity and abstract thinking that you have to do to take advantage of these machines. And, it is a very creative task to figure out how to fixture and work on these relatively complex jobs. And you get to do things you can't really do on a CNC machine. It's not really practical to do a lot of single operation repairs on a CNC anything. And we can do that on these, and we can do really truly weird one-off parts. Like, I had a part come in and one end had threads that were damaged on this, and I've also done this on firearms where it's not practical to pull the barrel, but you can actually put a center in the chuck, and the center can be this long, and you've got the part sleeved over it, supported with this live center on the other end, and you can work on it, and I can work on square parts and spin them in a circle, because there's creativity in fixturing. I'm trying to find, I guess this is a sense where you can have your reference surface is physically inside of a tube, and you can support it with a relatively long center. I think I have one over here. Yes, here it is. So this is another one where it was a relatively short distance I had to span. So I popped this in the headstock and just turned the center smaller, so it would fit inside something. And you get to do a lot of creative things like that, and you get to use your machines in, dare I say, unconventional manners, but they are quite conventional. I mean, that's what these are for. These machines are for fixing things and making things, and as long as you're not putting yourself or the machine at risk, that's what it's meant to do. It's meant to make parts. It's meant to be more limited by you than it. And that, I think, is leading into the toolbox fallacy, which is the idea that you need something to do something else, and you often don't. Now, there are hard limiting factors on what you can and can't do, but often there really aren't. So when you keep an open mind and you're willing to try and do things, I think you will thrive in a shop environment like this one, where really you kind of have to think on your feet. I don't always have the right tools to do things. In fact, I usually don't. Usually I'm scrambling to find an unconventional way to get something done because I just don't have the time, money, or resources to get what you need to do the job on paper. So I'm just going to cut over and demonstrate threading really quick, and I hope you like listening to me talk, and I think you're going to like watching the machine run. This is a very impressive machine, even just this little lathe. The amount of material you can remove per hour I'm always impressed, because once in a while I figure something out and all of a sudden I'm 10 or 15% faster, and it's like having a new machine. So you can see here, I'm just taking a few passes on the machine. I set the machine to cut 20 threads to the inch, and I also made sure that the threading dial was actually engaged on the lead screw. It's a good idea if you have change gears in your lathe to make sure you have the right combination of change gears in. A scratch pass works, or manually opening the cover. You'll also see there that chart tells you what position you can engage the half nuts in. And I never assume I remember it off the top of my head. I mean, there are a couple of threads you cut. See, I'm just checking it here. There are a couple of threads you cut where you can only cut them in one or two of the positions. 20 TPI, for example, you can engage in any position. And there are a couple of even inch threads where you can't disengage the half nuts at all. So the half nuts are basically just a thread, literally a nut that's been split in half that you open and close on that lead screw. So it's just really like it's shows in the video. You just go in, you take your pass, you back it out, back the tool out, and just keep repeating, rinse, repeat until you have your depth of cut. Now, in this case, I just used a nut as a no-go gauge, and it works. It's not the most precise way to do it, but for what this is, which is just a really quick demonstration, I don't think there's any point in trying to cut super precise threads. Like, this is a super beginner's guide. Most of you guys probably don't even own a lathe and may never own a lathe. You might have never seen one in person. So just for introductory purposes, let's try to keep it simple and accessible. And I like single point thread cutting. When you're in the rhythm of it, it's pretty relaxing. I think I was doing these cuts at either 220 or 270 RPM, which is really a little bit fast for me, at least, on 20 TPI. It's just annoying. I would love to have like 140 RPM. I think that'd be the sweet spot for most of the threads I cut, just between reflexes and everything else. But no machine's perfect. If I wired this up with an inverter duty motor on 3-phase, I could get all of the speeds I wanted. But I'm gonna wait until the motor dies because that's a low priority. Now, kind of as a tip off to the mill skills video, I think what we're gonna do
I
is
had to
just have a
stop and
talking
pause the video
video
because I needed to
with
find
not
my
having the machine running.
quarter 20 nut.
But the
And
next
there we are.
video will be
Single point threads cut on the
probably
lathe.
squaring stock
Now
and
this part was
starting to
bent a
make
little
some
bit, so I need
custom
to
fixture
take more
blocks. I
off than
think
you
I
really
alluded to
should
that
just to get
earlier
this
in
to
the
thread
video.
on.
And
And
see how it
it's
just
slightly
threads on here.
oversized
It's a little
1/4 inch.
snug, but you know what?
But
It'll work.
you kind of get
It's
the
brass.
idea
You
once
put
you
that in
get a feel
steel,
for
it
things.
forms fine.
It's pretty quick to do these
So
projects. Now,
it's hard to
I'll
decide.
just
I
show
think
you
that the
a teaser.
5 to 10 minute discussion and then 5 minutes of the machines running is a good format to get people thinking about what you can do on the machines. But
Of I
it's
think what
also
we're going to
hard to
start in
really
the
hit
milling machine
all of the
project. Now these are
important
called 1, 2,
educational
3
parts
blocks.
and
Now
really
I have a piece of
discussing what's
material
capable.
where we
See
can
here?
make it
Yep, that's a 1, 2, 3 block.
about
That's a
1
shop
inch
made
this
one. I
way.
don't know where I
It'll
got
be
it,
about
but
980 thousandths this way
I'm
and about 2.5
explaining
inches
here
long. And
about
I
the
can
size
make a pair of
material I
those. And that's
have.
still a
I
really good
decided to do
size
a
for setup
voiceover because the
blocks.
audio quality in my
What I'll
shop's
probably
not the greatest.
wind up
I
making
think the
them is
voiceovers do
1
better,
inch by 2
and that's
inches
going to be
by
our
kind of
intro to
a
mill
not
skills and
1 inch
probably our
dimension.
intro to a surface
So I can
grinder,
still use
because
them with
once
regular
these are
1, 2,
hardened, you
3
can't touch them on
blocks.
a milling machine. You have to grind them. And all
And
of
I think
these
that'll be a
tools
good
really feed
video to
back into
introduce
each
the
other.
surface
Like, you're
grinder as
always
well,
making
because
tools or
that's
making parts
that's a
that require
tool I
2 out of the
think
3
even people
machines
who
or
are
3 out of the
exposed
3
to
machines, at
machining
least when
might
you
not
have
have
all
a
of them.
familiarity with.
Like, I've had projects that
People know what
will
a
start on
milling
the milling
machine is, people know what a
machine or
lathe
start
is,
on the
people know what a
lathe,
drill press
go to the
is,
mill,
but
go
you
to the
show them a
lathe,
surface
then
grinder
they
and
go
they
to the
get
drill press,
confused.
and then they
Now,
go
thanks for
to the
watching, guys.
grinders.
I hope you
So
enjoyed
thanks
and
for
found this
watching, guys. I
informative.
hope you enjoyed
It's
it,
always a
and
pleasure getting
please
to
like,
share this
comment,
stuff with
subscribe, and
you.
share. It's always a pleasure getting to share this information with you guys.